In 2 days, the interstellar object 3IE Atlas will make its closest approach to Earth. December 19th is also a new moon, meaning this is the best viewing opportunity we will ever get. We are continuously updating you on 3I Atlas, the interstellar visitor that is capturing the attention of astronomers worldwide. With every observation, it reveals new and unexpected changes, from strange color shifts to mysterious chemical signatures. This comet is unlike anything we have seen before, and the journey it is taking through our solar system is full of surprises. The next update will shock you more than ever. The faint glow that turned green. When astronomers first spotted 3 Atlas, nobody expected fireworks. It looked like just another faint smudge drifting through the telescope's field of view. The kind of object you log, note, and move on from. Early observations showed soft reddish tones, the signature of dusty material far from any significant heat source. Scientists figured they were looking at a quiet traveler, maybe interesting for a few papers, but nothing that would keep them up at night. They were wrong. As weeks passed and the comet crept closer to the sun, something strange started happening. Sensitive instruments began detecting a new color bleeding through the coma, a faint green glow. At first, it was barely there, like catching movement in your peripheral vision. Then it grew stronger. Night after night, observation after observation, that green light intensified until there was no denying it. Something inside this ancient visitor was waking up. This was not random. This was chemistry announcing itself. Here is what happens. As 3 Atlas warmed after passing perihelion, the point where it swings closest to our sun, frozen ices that had been locked inside for billions of years began transforming directly into gas. Scientists call this sublimation. When those ancient ices break free, they release gases and fine dust that form a glowing cloud around the nucleus. Then sunlight does something magical. It interacts with these gases and makes certain molecules shine in very specific colors. The culprit behind this eerie green glow is a molecule called diatomic carbon, or C2. This molecule does not glow on its own. It needs energy. When sunlight strikes it, the molecule absorbs that energy, gets excited, and then releases it as visible green light. From our perspective on Earth, even the most powerful telescopes only see a soft haze. But to scientists, that haze is screaming with information. It tells them exactly which molecules are present and how active this comet has become. What makes this transformation genuinely unsettling is the timing. The color shift did not happen overnight. It developed gradually, layer by layer, suggesting that deeper and deeper regions inside the comet are now being exposed. Every new burst of gas hints that sunlight is finally reaching materials that may have been sealed away since before our own solar system even existed. Think about that for a moment. We are watching ices that formed around another star in another planetary system. Finally seeing our sun for the first time. Because 3 Atlas originated somewhere else entirely, those materials may not match anything we have ever studied. Its chemistry could follow rules shaped by a completely different stellar environment, different temperatures, different radiation, different building blocks. We simply do not know yet. As the comet continues shedding gas and dust, its appearance becomes a living record of its internal structure. The green glow is not just pretty. It is evidence that complex chemical reactions are unfolding in real time right in front of our telescopes. Layers of ice mixed with carbonary compounds are being stripped away one by one, revealing a history written far our sun's influence. For astronomers, this is both thrilling and deeply unsettling. Every color change means the comet is evolving faster than anyone predicted. What looks calm one night can look dramatically different the next. And each transformation brings new questions. The green glow is a signal that something deeper is happening, something telescopes are only beginning to capture. This color shift may be just the first sign of an unprecedented transformation lurking beneath the comet's surface. X-rays and solar wind, a cosmic collision. While the green glow captured attention from optical telescopes, something far more surprising was unfolding visible light. Space-based observatories started picking up faint X-ray emissions coming from 3 Atlas. This discovery sent shock waves through the scientific community. Comets are cold objects. They are essentially dirty snowballs tumbling through the void. They should not naturally emit high-energy radiation. Yet there it was, a soft but unmistakable X-ray signal surrounding this interstellar visitor. The source of these X-rays is not heat. It is violence. As the comet releases gas into space, it creates a cloud of neutral atoms and molecules around its nucleus. Meanwhile, our Sun is constantly blasting the entire solar system with the solar wind. A relentless stream of fast-moving charged particles. When these charged particles slam into the neutral gas escaping from the comet, an exchange of energy occurs. Electrons jump between particles. That sudden transfer releases energy in the form of X-rays. This process transforms the space surrounding the comet into a glowing interaction zone. Invisible to human eyes, but lighting up brilliantly in high-energy wavelengths that only specialized space observatories can detect. For scientists, this is pure gold. Each X-ray photon carries clues about which atoms are present in the comet's gas cloud. Oxygen, carbon, and other elements leave behind unique signatures. By studying these patterns, researchers can map the comet's chemistry in ways that optical telescopes cannot. What makes 3I Atlas stand out is how unusual its X-ray profile appears. Compared to many comets born in our own solar system, the signals from this object look different in strength, different in structure. That suggests the gases streaming from it may not follow the same chemical balance scientists are used to seeing. The interaction with our solar wind seems more complex, almost as if the comet is releasing materials that respond in unexpected and unfamiliar ways. This discovery also changes how scientists observe the comet over time. X-ray emissions can shift quickly as the comet's activity increases or decreases. A stronger burst of solar wind can brighten the signal dramatically. A sudden eruption of gas from the nucleus can reshape the glowing region almost instantly. Watching these changes unfold allows astronomers to study the comet as a dynamic living system rather than just a static object drifting passively through space. More importantly, X-rays reveal what lies the visible surface. Dust clouds and sunlight reflections can hide critical details, but high-energy emissions cut through that noise like a knife. They expose the invisible interactions that define how this comet behaves when faced with a new star for the very first time. For an object shaped around another sun entirely, this first encounter with our solar wind is like a stress test. It is forcing hidden chemistry out into the open, whether the comet likes it or not. As data continues pouring in, scientists are realizing that these X-ray fingerprints do not neatly match known categories. They hint at processes and materials rarely if ever seen before. This is no ordinary comet reacting in familiar ways. It is an interstellar body revealing its secrets under pressure. As excitement around 3I Atlas intensified, scientists realized that no single telescope could fully capture what was happening. Spacecraft views from every vantage. Ground-based observatories offered valuable data, but their view was limited by Earth's atmosphere and restricted to a single line of sight. To truly understand this visitor, astronomers turned their attention to space-based eyes positioned across the entire solar system. What followed was one of the most coordinated observation campaigns ever focused on an interstellar object. The Hubble Space Telescope played a central role. From its orbit high above Earth's atmosphere, Hubble tracked the comet's motion with remarkable precision. Its images revealed fine details in the coma that ground telescopes simply could not resolve. Subtle jets appeared, showing exactly where material was actively escaping from the surface. These jets changed over time, suggesting uneven heating and complex internal layering rather than a simple uniform icy body. But Hubble was only part of the story. Other spacecraft positioned far from Earth also caught glimpses of 3I Atlas. Missions operated by the European Space Agency, including JUIE on its long journey through the outer solar system, observed the comet from angles impossible for any Earth-based instrument. Even orbiters around Mars recorded faint signals, offering side views that helped scientists track how the comet's tail and gas cloud spread through space in 3 dimensions. Each new vantage point added crucial depth. When scientists combined all these observations, they could reconstruct a 3-dimensional picture of the comet's structure. Instead of a flat image, they now saw how gas expanded in all directions, how dust trailed behind at different speeds, how solar radiation shaped the coma from multiple sides. This layered view revealed that 3 Atlas is far more active and far more uneven than it first appeared. These multiple perspectives also helped confirm that the comet is rotating. Changes in brightness and jet direction over time suggested a slow spin, exposing different regions of the nucleus to sunlight. Some areas responded strongly, releasing bursts of gas. Other regions remained quiet as telescopes shifted their focus from light and motion to chemistry. 3 Atlas began telling an even deeper story. Using spectroscopy, scientists started breaking its glow into fingerprints of individual molecules. What emerged was not just interesting, it was genuinely strange. Early data revealed unusually high levels of carbon dioxide compared to many comets from our own solar system. This alone made researchers pause and take notice. Carbon dioxide is common enough, but its abundance can reveal critical information about the temperature and environment where a comet originally formed. Alongside the carbon dioxide, there were clear hints of methanol and complex hydrocarbons. These molecules matter because they are stepping stones in chemical evolution. Methanol forms on icy grains floating in the coldest regions of space and can later break down into more complex organic compounds. Seeing it in an interstellar comet suggests that similar chemical processes may be common across the entire galaxy, not unique to our Sun's neighborhood, not special to our corner of space, universal. What truly excites scientists is how these molecules differ in balance and proportion from what they expected. Solar system comets tend to follow familiar patterns, chemical signatures shaped by our Sun's birth cloud billions of years ago. But 3 Atlas appears to break some of those established rules. Its chemistry may reflect a star system with a different temperature profile, different radiation environment, different disk composition. In simple terms, this comet may be carrying the chemical accent of another star. These chemical fingerprints matter tremendously because comets are essentially time capsules. They preserve material from the earliest days of planet formation, locked away in ice for billions of years. If 3I Atlas formed around another star, its ices record conditions from a place we can never physically visit. Every molecule released into space is like a sentence from a long-lost history book. By reading that chemistry, scientists can compare how planetary systems build themselves across the galaxy. Some of the detected compounds are also directly linked to life-building chemistry. Carbon-rich molecules are essential ingredients for more complex organics, the very building blocks that eventually led to life on Earth. Now, this absolutely does not mean life exists elsewhere, but it powerfully strengthens the idea that the raw materials for life may be widespread throughout the cosmos. If comets like this one are common, they could spread complex chemistry between star systems over cosmic timescales. In this way, 3 Atlas becomes more than just a visitor passing through. It becomes a messenger. Please like and subscribe channel.